So on this question, we want to factor completely using the formula for sum or difference of cubes. We've got the expression 14t cubed plus 14. Now, one thing to keep in mind is that even though it says to factor the sum or difference of cubes, we want to first factor the greatest common factor. So we do have a greatest common factor of 14. So that greatest common factor of 14 would give us t cubed plus 1. Now we factored the greatest common factor, and inside the parentheses we want to look to see if we have a sum or difference of cubes. So a sum of cubes would be a cubed plus b cubed. A difference of cubes would be a cubed minus b cubed. I've got t cubed, so definitely have a cube in the first term. We've got a plus, so we have a sum. And then 1 is a special number because 1 to any power is 1. So 1 cubed is the same thing as 1. We do have a sum of cubes in that parenthesis. So we can think of this as 14 times t cubed plus 1 cubed. Now, we do have that sum of cubes, but we have to know how to factor that pattern. So the pattern for that is going to be a plus b. We use the same sign that we had in the original. So we have a sum, we'll use a sum. And then we have a squared minus ab plus b squared. So this is the pattern that we follow for sum of cubes. Our a is a t and our b is a 1. And if we follow that pattern, we would get 14 times t plus 1 times t squared minus t. So this term right here is a times b, t times 1 is t. And then the last term, 1 squared, is 1. So completely factored, we have 14 times t plus 1 times t squared minus t plus 1. On this example, we want to perform the subtraction. Negative 8x to the 5th minus 5x squared plus 6x minus negative 5x to the 5th minus 10x squared plus 10. So in this example, we have parentheses around this first polynomial, and the parentheses around this first polynomial don't really mean anything. We don't need to keep them. And the reason why, if I look in front of the parentheses, there's no coefficient written here. We can think of it as a coefficient of 1 if there's nothing there. And if we distribute a 1 to all of these, none of these terms change. So this first parenthesis, I'm just going to drop, keeping everything exactly the same. However, in the second parenthesis, we have to be more careful. These are grouped together, and if we look in front of the parenthesis, we have a minus. This is like a negative 1. And in order to get rid of these parentheses, I need to distribute that negative 1 to every term inside the parenthesis. So negative 1 gets distributed to every term inside the parenthesis, and we'll get plus 5x to the 5th plus 10x squared minus 10. So that's how we remove the parentheses. Once they're gone, then we can combine like terms. So I have x to the 5th on these two terms, negative 8x to the 5th plus x to the 5th combined together to be negative 3x to the 5th. Then we have two terms with x squared in it, negative 5x to the 7th plus 5x. Sorry, my sloppy handwriting is getting the best of me here. That's a squared. Negative 5x squared plus 10x squared combined together to be 5x squared. And then the remaining terms of 6x and 10, those are not like terms, so I'll just copy those down. plus 6x minus 10. So for the subtraction, we get negative 3x to the fifth plus 5x squared plus 6x minus 10. On this example, we want to find the quotient and the remainder using long division. We're going to divide x to the fourth plus 7x cubed minus 52x minus 11 by x plus 5. So when we set up our long division problem, I want you to notice that the numerator has a missing term. We have x to the fourth, x cubed. We don't have an x squared, and we have x to the first, and we have our constant. So when I set this up for long division, I'm going to put a placeholder in for that x squared, and that's a precaution that we do so that we make sure that we only add like terms. So we're dividing by x plus 5, and we're going to divide into the numerator, x to the fourth plus 7x cubed. I'm going to put my placeholder for the x squared. My placeholder is 0x squared. 0x squared is the same thing as 0. And I'll copy the rest of the numerator down, minus 52x minus 11. And now I'm going to go through that long division process. With the long division process, we're going to focus on only the first term of what we're dividing by and the first term of what we're dividing into. So we're going to think x divides into x to the fourth, x cubed, or if you prefer, you can think of it as multiplication. X times what will give me x to the fourth, and that's going to be x cubed. We write that x cubed up here at the top. And remember, earlier we ignored the plus 5 and only focused on the x, but on this step we don't want to ignore the plus 5. We want to multiply x cubed times both of these terms. X cubed times x is x to the fourth. X cubed times 5 is 5x cubed. Now, in the process of long division, on this step, we need to subtract. We're going to change the signs to do that subtraction. So both of those were positive, they became negative. Now we have x to the fourth minus x to the fourth. Those zero out. 7x cubed minus 5x cubed becomes 2x cubed. And I'll carry down my next term, 0x squared. Now we repeat the whole process over again. Once again, focus on the first term here, by what we're dividing by, and the first term of what we're dividing into. X divides into 2x cubed, 2x squared times. Or you can think of multiplication. 2x squared times x gives us the 2x cubed. So once we get that number, we're going to multiply that number by both of these terms and write it down here. 2x squared times x is 2x cubed. 2x squared times 5 is 10x squared. I need to subtract, so I'm going to change the signs. Bless you. 2x cubed minus 2x cubed zeroes out, and we have 0x squared minus 10x squared is a negative 10x squared. And I'll bring down the next term, minus 52x. We're going to repeat the process over again. Focus on the first term of x and the first term of negative 10x squared. X divides into negative 10x squared, negative 10x times. Or if you prefer to focus on multiplication, negative 10x times x gives you negative 10x squared. Let's multiply that number by both of these terms. Negative 10x times x is negative 10x squared. Negative 10x times 5 is a negative 50x. Now we need to subtract. So we'll change the signs. Both of these are negative. We'll make them positive. Negative 10x squared plus 10x squared zeroes out. Negative 52x plus 50x combines to be negative 2x. And we bring the next term down. We'll repeat the process one more time. Focus on the first term in each one of these. X divides into negative 2x, negative 2 times. Negative 2 times x gives us negative 2x. We're going to multiply that negative 2 times both of these terms and write it down here. Negative 2 times x is negative 2x. Negative 2 times 5 is negative 10. We need to subtract, so we're going to change those signs. Negative 2x plus 2x zeroes out. Negative 11 plus 10 is negative 1, and we've reached our final step. We've got our quotient, which is x cubed plus 2x squared minus 10x minus 2, and our remainder of negative 1. For this question, we want to factor completely using the formula of sum or difference of cubes. We have 27r cubed minus 64. So taking a look, I don't see any common factors that I could factor out. And the directions do specify that I want to try to factor with sum or difference of cubes. So the pattern that I'm looking for sum of cubes would be a cubed plus b cubed. And for difference of cubes, that would be a cubed minus b cubed. And I see the r cubed. So the pattern's probably there, but I need to know what 27 is, if it is a perfect cube, and also if 64 is a perfect cube. 27 is 3 times 3 times 3. So I can write 27 as 3 cubed. And 64 is 4 cubed, 4 times 4 times 4. So this is a difference of cubes. And now that I recognize that it's a difference of cubes, I want to follow the factoring pattern for that. The factoring pattern is going to be a minus b times a squared plus ab plus b squared. So now that I've got it written in this format, I can see that a is 3r and b is 4. And if I factor, the pattern would be 3r minus 4. So that's this first part of the pattern. 3r is a, 4 is b, so I have 3r minus 4. And I want to have a squared, so 3r squared, plus a times b, plus 3r times 4, plus b squared, plus 4 squared. So I have 3r minus 4. 3r squared is 9r squared. 3r times 4 is 12r, and 4 squared is 16. So using that difference of cubes pattern, we got 27r cubed minus 64 to factor to be 3r minus 4 times 9r squared plus 12r plus 16. So on this question, we have solve for x, and we're given a compound inequality. Negative 2 is less than or equal to 5 times x minus 11 is less than negative 4. So typically with a compound inequality, your goal is to get the variable by itself in the middle. But I see something a little bit strange in this compound inequality, and so I included these extra instructions here type D and E does not exist if there's no solution. So this is something that I'm recognizing right off the bat that seems a little bit off. And with the compound inequality, you typically would have something that looks like this. Let's say 3 is less than x is less than 8. Okay, so this is a typical way a compound inequality would look. And the reason why it's called compound is because it's actually two inequalities that have been pushed together. And the two inequalities are this one right here, 3 is less than x, and this one right here, x is less than 8. Now, thinking of these two simultaneously, this one says that 3 is less than x, or if we reverse that, x is greater than 3. And this one says x is less than 8. So we're talking about numbers that are less than 8 but greater than 3. So on the number line, we're talking about all the numbers that are between 3 and 8. So the thing that I recognize in this pattern is that these inequalities seem to translate. This is the lowest number, x is next, and this is bigger. Whereas the one that we're given doesn't match that pattern. This number on the left should be the smallest number, the lowest number, and this one the biggest. On the number line, -4 is smaller than -2. So right from the start here, this compound inequality is not following the right pattern to have solutions. So it would be essentially like we were saying 8 is less than x is less than 3. And there are no numbers that are bigger than 8 and also less than 3. So we're going to get no solution on this one. If you were to work it out, let me give you some details on that. You would get -2 is less than or equal to 5 times x minus 11 is less than -4. We would distribute the 5 inside. That would be 5x minus 55. And now we would get x by itself. So we would add 55 to each part. That gives 53 is less than or equal to 5x is less than 51. And so once again, look at these numbers on the ends. 53 is less than 5x, which is less than 51. That doesn't make sense. 53 is not less than 51. If we keep going, we divide by 5, and we get 53 over 5 is less than or equal to x is less than 51 over 5. Now that these are fractions, it's harder to notice, but 53 over 5 is a larger number than 51 over 5. But this inequality doesn't make sense. There are no solutions to it. And so we're going to type D and E. Does not exist. So on this example, we want to simplify, write the answer without negative exponents, and assume that no denominator equals 0. We're given x to the -8 times j squared times n over x to the 9th j to the -4th n cubed. Now I can see that I have some variables with the same base. I'm going to be able to use my exponent properties to combine those together. But I also notice that I have some negative exponents on this one. Those can be a little bit confusing, So it's my preference to rewrite the problem so that it doesn't have negative exponents first. It's not the only way to do the problem, but it will avoid any issues with those negative exponents. So when you have a negative in the exponent, that means reciprocal of the base. And because of that, we can apply the negative by just moving the factor to the opposite location. So this factor has a negative exponent and it's in the numerator. So if I move that factor to the denominator, it applies the negative and the negative goes away. The same thing happens with this factor. It has a negative in the exponent. I'm going to move that factor to the numerator and that applies the negative. So applying those negative exponents would give me j squared times j to the 4th times n over x to the 8th, x to the 9th, n cubed. So we apply the negative exponent and it moves the factor. If you're in the numerator, moves it to the denominator. If it's in the denominator, moves it to the numerator. And now I'm going to deal with the factors that I have left. I have j squared and j to the 4th. Those are being multiplied, so I'll add the exponents. That's j to the 6th. That should be a j to the 6th times n. And in the denominator, I have x to the 9th and x to the 8th multiplied. Those combined together, I'll add exponents, and I get x to the 17th. And then finally, I have these n's. One n is in the numerator and one's in the denominator. So I'll apply the quotient rule, and with the quotient rule, we subtract the exponents. So that would give me j to the 6 times n. This n is to the first power, so it's 1 minus 3, that's negative 2. And I don't want to write any negative exponents, so let's move that factor to the denominator. I have j to the 6 over x to the 17th times n squared. We want to find the quotient and the remainder using long division for x squared plus 4x plus 11 over x plus 3. So let's set up our long division. This time we don't need a placeholder because we're not missing any terms. We have the squared, the first power, and the constant. We're going to divide x plus 3 into x squared plus 4x plus 11. We want to start by focusing on the first term in what we're dividing by and what we're dividing into. X divides into x squared, x times. Or you can think of it as x times x is x squared. And now we're not going to ignore the second term here. We're going to multiply this x times both of these terms and write it down here. That would give x squared plus 3x. And now in the process we need to subtract, so we're going to change signs. X squared minus x squared is 0. 4x minus 3x is x. We'll bring down the next term. Now focus on the first terms again. We're repeating the process over again. We have x and x. X divides into x one time, so we'll put a plus 1. We're going to multiply that 1 times both terms. 1 times x is x. 1 times 3 is 3. And then we'll subtract. X minus x is 0. 11 minus 3 will give me an 8. And now I've got my remainder. So my quotient is x plus 1, and the remainder is 8.
Thank you for checking out my videos. Have a great day.